Bismillahirrahmanirrahim. Today's talk is about deep learning concepts, and I'm Dr. T. Muzafar Malik. I'm working as Associate Professor in Department of Computer Science in Yale University, Bhutan campus. The basic purpose of this talk are the basic participants or audience targeted are of graduate and undergraduate level students, and those who need to understand what the basic concepts of e-learning are. In today's talk, we will start with the understanding of the meaning of machine learning and the difference between machine learning and deep learning. And there are multiple types of neural networks. We will talk about those different types which are majorly popular. Among those types, we have convolutional neural network, which is mostly utilized when considering deep neural networks. Among those convolutional neural network types, architectures, I'm going to briefly give introduction of AlexNet. What is meant by from machine learning? We are actually trying to make machines capable to behave at least in understanding like human brains. For that, we need to provide a machine with data and the capability of algorithms to make them extract features from that data. So they can analyze data, categorize them, and represent them in solving our daily lab problems. Classically, machine learning was separated into categories. One famously known as supervised and other one is unsupervised. What is the difference between both of these two categories is in supervised, our data which we are trying to work on is labeled or pre-categorized. So we are working with the data which is labeled and we are trying to build groups out of it and make our machine capable of analyzing similar data in future when we bring in front of it. One way of supervised learning is through classification, and another is through regression. Regression is purely based on statistical tool, which divides different groups to providing both groups from each another. Whoever comes at whatever side becomes the part or identified as that group. Well, whereas classification, there are many other methods like decision tree. We have K-mean algorithms. We have SVM, sport vector machines, and many other ways of classifying on the behalf of supervised learning. On the other hand, unsupervised learning, where our data is not labeled, so we need some mechanism to find out the difference between data categories. So we use the concept of grouping. For that, we use the association mechanism in which we look for the relationships, closer relationships, on the behalf of distance they have from each another. We have clustering mechanism. In that, we look for their similarities. On behalf of their similarities, we group them, and whatever the label we are giving it, it can identify in future. Dimensional reduction, another way of training our machine, is to reduce the whole dimension, the smaller version, which can represent the bigger picture of our data. It is somewhat similar to what we can say a sampling of the actual data. A sample may represent the whole data. So that was a classical way of representing our machine learning concept. But nowadays, machine learning has evolved. Why it has done that? Why it has become more expanded? Because now we have power in the form of distributed systems. We have virtual machines. We have cloud computing. We can have much power in our hands, which were previously missing in 1980s when this concept initiated. That was the one reason deep learning never get fame in 1980s. First practical example of machine learning was AlexNet in 1990s. Was practically introduced, but was didn't get any fame. Reason that we didn't have the power what we have now in the form of GPUs and others. Okay, leaving classical learning behind because we have seen it, what it is representing. We have other classification of machine learning in the form of ensemble methods, which are used to enhance the classical learning by using some probabilistic models. We have boosting, we have stacking, we have tagging, which are to improve our previous classical learning methods. Reinforcement learning is actually built on agent-based development. Agents are trained, they are waiting for the agenda, the case they have trained for. When they receive the data, similar data, they produce a reward of it. If the reward is better, we evolve our agents. If it's not, we just remove it or reject it. Now, these all are the enhancement of the previous classical learnings, but now we are looking for something which is more closer to human brain, which is neural networks, where the concept of deep learning appeared. So we have in neural networks, we have perceptrons, we have convolutional neural networks, we have autoencoder, we have generative adversarial networks, we have recursive, recurrent neural networks, and many more. These are few of them. This is the abstract view of the domain where this deep learning came from. Artificial intelligence is about a study which helps us to build a machine capable of closing our relationship of our thinking capability closer to the machine. How it does it? It has the capacity of problem solving, it has the capacity of learning. When we talk about learning, more specialized form is machine learning, which is a specialized form of AI. Machine learning, I have gone through it in our previous slides. Let's move forward with neural networks. It actually maps the concept of neurons, which are passing their knowledge to next neuron, what they have learned, and next neuron goes in depth of that and passes this knowledge to another. The first neuron becomes input for the next neuron. This is the major basic concept of neural networks. Whereas deep learning is all about the power we have. As much we have the power, we can deep dig in our features. Our major task is to recognize the patterns, extract the features of the data, similar features. For example, in your daily life, what I, I do for recognizing something which is in front of me, it is the similarity which I have brain trained for understanding that thing. For example, I have a keyboard in front of me, I have a speaker, I have people in front of me. So the things which are matching through within my neurons are triggering that there is a human, there is a speaker, there is a mic in front of me. So similar capabilities are built in your computer. So if it is provided with the visual capacity, it can understand what is in front of that visual device through its algorithms. This is the first one, the first figure at the left is the neural network, which has the hidden single layer in 1980s, which was less capable because of the less availability of computational power. So the accuracy was less. No one got interested in performing similar tasks in using neural networks. Whereas in deep learning, nowadays we have the computation power, so we can go from defining picture, capturing its pixel values, highlighting their intensities, uh, through those intensities, which in fact becomes a frequency, we can identify the edges. Through edges, we can identify the combination of edges, what they represent in real. Uh, and through those combinations, we can identify multiple features. And finally, we can come up what this picture is about, a human and name of that human. This is the abstract view. Among this, actually, what is happening, we are building, this is representing convolutional neural network, where each layer is representing a layer of convolution and a pooling concept and further feature extraction. We will look into this thing in later slides. So what we have in the form of applications nowadays, above all, classical algorithms are getting replaced by the current deep learning concepts. Everyone is trying to build up a model which can identify objects through photos or videos, or go for speech recognition, or synthesize them, or capture the semantics out of them, used for the image processing, or converting into something else, or bringing something else from it, or reproducing something which didn't exist, or translating something which was not possible previously. So popular architectures defined for neural networks are perceptron, convolutional network, recurrent network, and autoencoders. This is the summary I got from a paper, survey paper, published in ACM Computing Surveys, which represents different deep learning networks and their capabilities in different problems or areas. For example, we have a recursive neural network, we have a recurrent neural network, we have convolutional neural network, we have deep belief network, okay, deep Boltzmann machine, and so on. Whereas starting from recurrent neural network, it majorly is most fruitful when used for NLP problems, whereas RNN is more for NLP and speech processing. CNN is for initially was built for image processing or image recognition. Then also get involved for supporting NLP, speech processing, and so on. Deep Belief Network was the initial version, uh, which further evolved into CNN. What it does, it helps to connect different neurons to get in-depth information. Supposedly, in initial stages, there was two layers, which help us in understanding what is going on while extracting features. These are a few examples of deep learning neural networks. First one is convolutional neural network, where CAD, we have identified a part out of it, like we are getting the slide of a slab, identifying the edges of it, and then converting or reducing it by using the concept of pooling, and finally going to the end of this whole model. This is the just abstract level representation. We will go into deep into this specific model at least. Next is recurrent neural network RNN, where we are working with the phrases or with the NLP problems. While it is more suitable for that, because look over here, we have H. Through our learning, we got the output in the form of audio. We combined with H, the neural network with the E, and we have the combination sound of HE. And similarly, we are moving forward like this. This is why we are calling it recurrent neural network. Instead of going the one way, we are using one learned model to produce another version of it. It is some sort of sequential learning mechanism when we are working with recurrent neural network. Then we have multi-layer perceptrons. It is what it represents. We have some handwritten information. We are extracting the information in the form of pixels. Pixel informations are basically used to connect on the basis of feed forward mechanism in the machine. Wherever they are linked, finally we get our result where the most bits are found. Okay. As initially I have said, I will go only on one type of the neural network, that is convolutional neural network. The basic concepts involve, first of all, the input. Input is image. Image has three representation of it in the form of pixels, considering it has the values of pixel in red, green, and blue. So we have three tables of similar information. What we do initially in our first convolutional layer, we apply some weights on it. Weights are those which help us in image processing. These are nothing new. These concepts are available in image processing a lot uh, era before deep learning was introduced. So what they do, they are pre-calculated weights which help us in identifying specific area which are called edges in an image. So these are the actual values of the image, this one, and these are zeros are being added for padding purpose. Why they are done, this is done for, it is due to the window. Window is required to be 3 or 3. I'm not going into detail of what image processing technique it is. What it does, it can compute the values, weights, what we have given it. Those weights are highlighting the which part of the image is containing more information in form of intensity of our pixel values. That is our interest area. So this is what a feature map. Complete set of these things are called feature map. This is our convolution layer at initial stage and forward and so on. So what happens next is we go for from convolution layer to pooling. In our case, in majorly, we use max pooling, whereas there is a variation of average pooling or min pooling. But in convolution neural network, max pooling is used. What they do, they down sample it. What we have here is the, sorry, we have the summation of the weighted values. We pick a window where we collect out of four combination window of complete window, and we select the max value from it. You can see we have converted this whole window into smaller window. Our only interest is this value 6, 8, 4, and 3. This represents the whole 4-bit value of the previous one. It contains the value 4. Our interest area mostly lies over here and there. So what happens majorly in simplified CNN model, we have two convolutional modules. One module is built up of one convolutional plus ReLU. ReLU is basically rectify linear, I think unity, the unit. It does something like this. If there is a negative value within our summation, it just removes it. It normalizes our values. So our computation doesn't get wastage or wrong direction. So it is used for the normalization purpose. First convolution, then we go for max pooling. Then again, on achieve max pool values, we go for convolution layer 2, then max pooling, then whatever we have received, we try to connect them to extract the features, and finally fully connected brings us to classification of what we are trying to find out. In our case, this becomes Einstein in specific problem. This is what is called AlexNet. AlexNet is one practical implementation of CNN, which got really fame. As you can see among the different pictures, what it identified against this one. where this object lies, and still it identifies up to some significant percentile that what it is. Whereas this ship, whereas this motorcycle or scooter, this animal, how it is possible when at the previous machine learning, whenever we are trying to find an object, if it is in middle of the picture, then it gets correctly identified. But in deep learning, wherever that object is, it correctly identified, almost correctly identified. For example, in this case, it most probably identified what it is, but not the way we want it to be. It was classified as grill, a type of vehicle, whereas it identified the maximum probability of convertible vehicle. Okay. Similar things happens in machine learning or concluding this deep learning. So most probably in 5 minutes this will end. I will restart it to end it properly. All right. We will start from here. We have complete picture. We get a slide out of it. We add weightage in it. Then we make convolution on it. It becomes a huge amount of neurons who are getting connected on this specific part of the picture, which identifies features. Then this convolution layer is further minimized to have lesser values, but still our neurons will get increased because these neurons will connect with other neurons, these connect with other neurons, and this is getting deeper and deeper and deeper. And that is why the computation is required, the power hardware is required. Without that, we won't be able to compute it. Human can compute it, simple systems can compute it, they will fail it in computing similar problems. So we need something, GPUs, more CUDA or processing power. So this continues, we got feature extracted, we now look over here, whatever is defined over here, if in our test picture, this is found over this side or there, wherever it is, our model is capable of identifying it on the behalf of their linkage found in these neurons. Whatever we have connected and fully connected to this network, in our fully connected layer, in this CNN model, AlexNet, in one layer, we have 4,000 plus neurons. You can add up to how many layers we have and how much computation is required. But once this model is prepared, we can test this thing without wasting any time. Only training takes lot of time. These are the complete list, almost well-known neural networks. I can define them all of this, but it will take huge time. So I'm going to skip this one. Final words or conclusion, future of the machine learning is to see that machine gets the feeling, they can enjoy the intelligence. This was the prediction of Albert Einstein. In future, machine will become such capable that they can understand the feelings which are currently missing in the machines. Any questions? Okay, thank you for listening. Hopefully it was useful for the audience to have the basic understanding of deep learning.
Maybe I may have one question.
Yes, please.
Maybe it is irrelevant. If you go like some previous slides, this one, where you have written value. Does these networks, as this network is this network, is this network representing edge?
This specific part of this network, when it identifies what this character is, next it goes for the next character.
How we can
What actually it is doing, it is converting text into voice. First, it identifies how H sounds like, it produces that word, sound wave, then goes for the next character and goes for the combination of the sound. For example, it will become he. So the sound here, the output of this network becomes the combination of these two recurrent networks becomes he. Then the next version combines the L with he. What it becomes hell, most probably, and again L, then O becomes hello.
that's okay. I have a sound H. You can produce a way for that. And what method to associate this wave to this network? You have also you are also representing this wave with the network.
Yes, exactly.
Uh, is it very research?
Actually, no. What we have a data set. For example, when two characters appear with combination, what sound it will produce, we have a data set out of it. Our system connects those findings in H. For example, we have seen in our multi-layer perceptron hand-return information how they identify it. First, it will identify the H character. When it identifies it, it goes for the data set and sees what sound we have for it. It captures it and further goes for the next character, what is written, then identifies that character and sees what we have the combination of HP in our data set. And it goes on and on until we have a space there. It is all dependent on our implementation, how we have implemented it. Okay, thank you to everyone who have participated in this talk. Thanks a lot.